In the last section, we were introduced to the new notion of limits and how to evaluate them by looking at their graphs or constructing a table of values. But algebraically, what else can we do with them? In the universe of limits, there's a laws that we can use for our benefit and make our life easier as we compute the limits. The first two we have seen in the last section, that given any real number a and any constant c, the limit as x approaching a of the function x is a, and the limit as x approaching a of any constant is just that constant itself. But we want to know more about the limit operation. What else can we do? Let's say that if we suppose the limit at x approaching some number a of some function f of x, and the limit as x approaching a of some function g of x exists, then what can we say about the limit as x approaching a of the sum f of x plus g of x? If you have go for your gut feeling, you must have been right that this limit is equal to the sum of the two limits, that a limit as x approaching a of f of x plus the limit as x approaching a of g of x. And this is also true for subtraction, multiplication, and division with some caveat. So that gives us the limit laws. The following can be quite handful when you look at it in the formula form, but we can also consider this verbally. The first law say that if I have the limit of a sum, that will be the sum of the limit as I have shown earlier. Secondly, the limit of the difference is the difference of the two limits. Then the limit of a constant multiplied by the function f of x is just that constant multiplied by the limit of f of x itself. Also, the limit of the product is the product of the two limits. And lastly, the limit of the quotient is the quotient of the two limits, given that the limit in the denominator is non-zero, because we don't want to divide by 0. Now, let's look at an example. Let's compute the limit as x approaching 1 of 2 times x plus 3. We say that using the addition rule, we can rewrite this expression as limit at x approaching 1 of 2x plus the limit as x approaching 1 of 3. With the first limit here, we can apply the constant multiple rule to pull the 2 outside the limit. Thus, we have 2 times limit as x approaching 1 of the function x. Plus, for the second limit, we see that this is just limit of a constant, and we know that it would be the constant itself. So this limit evaluated to be 3. Finally, we see that the remaining limit is the limit of the function x. So, as we know, this will evaluate it to 1. So that would be 2 times 1 plus 3. So the final result is 5. In the textbook, you will see more examples of how these limit laws will be used to compute more complicated limits.